Welcome back, geometry students of all ages, shapes, and sizes. We're moving on in the unit of parallel and perpendicular lines, part 1. Right now what we're going to do is jump into some more about properties of parallel lines and parallel line theorems and their converses. So in the textbook, we're dealing with Chapter 3, Section 3, about proving lines parallel. Pay attention to that first word. You see that word? Proving. You know what that means? Proofs. But don't be scared. We're going to do just fine. Okay? We're going to be just fine. So in this particular section, we're dealing with some more theorems and their converses. And you can look at the stuff that's going on for pages 156 to 157. We have converse of this and converse of that and converse of the other. And you're probably thinking, what's the deal with converses? I love my Chuck Taylors. Is that what you're talking about? And no, it's not what we're talking about. We're not talking about shoes. We are talking about theorems. Okay, so there's a logical operation called the converse of a thing. And so I'll give you an example. Let's start with a theorem that we had learned in the previous lesson about parallel line properties. And if you don't know that lesson, don't even try this video. Like, stop here and go back. Okay, so if you haven't done the previous lesson, go back. So here we are. This is what we had learned in the previous lesson. If corresponding angles are congruent, then lines are parallel. So notice this has two pieces, right? Corresponding angles being congruent and lines being parallel. The converse, right, not the shoe, the converse, this logical thing that we can do is switch those statements around. That's the converse. So we can say then if lines are parallel, then corresponding angles are congruent. Okay, so that's, in this case, the converse of each of these things is true. Not all converses are true, but in this case, when it comes to corresponding angles and parallel lines, they are. So let's take a look at a couple things that you need to know. Here we have what in the book calls Postulate 3.2. It talks about labeling it the converse of the corresponding angles postulate. I don't need you to know this. I don't need you to know the name of it. I just need you to know it. Okay, so I don't need you to know the name of it. I just need you to know it. Okay, so you don't have to say the converse of the corresponding angles postulate. You just need to say if lines are parallel, then corresponding angles are congruent. In the same way that you don't need to know the corresponding angles postulate. You would just say this. Okay, so these are the things you don't need to know. You just need to say what they are. So all of these theorems down here, it's a similar thing. You don't need to know this as the converse of the alternate interior angles theorem. You're just saying if lines are parallel, then alternate interior angles are congruent. Or if lines are parallel, then same side interior angles are supplementary. Or if lines are parallel, then alternate exterior angles are congruent. It's the converse of what we had learned in the previous lesson. Okay, so once again, if you haven't done that previous lesson, problem. Make sure you do that. So now what we're going to do is to jump into some fun stuff. So here's problem number 1. We're going to dive into that and take a look at it. So I'll show you a funky diagram, okay, and then we'll ask which lines are parallel. If angle 1 is congruent to angle 2, we're going to justify our answer. Okay, so which lines are parallel if angle 1 and angle 2 are congruent? And we're going to justify the answer. So let's look at this diagram. Where are angle 1 and angle 2? Okay, so here's angle 1 and here's angle 2. Are they corresponding angles? Yes, they are. However, they're corresponding angles, but the most important thing to do is to identify the transversal. Okay, so if that's the case, what then is the transversal? Okay, so if those are corresponding angles, what is the transversal? So if these are corresponding, then guess what? M is the transversal. Okay, and if M is the transversal, what is it crossing? Okay, so what is this transversal crossing? It is crossing or intersecting, okay? It is intersecting A and B. Okay, so it's intersecting A and B. So we have to be able to identify that, all right? 1 and 2 are congruent, So then they're corresponding angles, okay, if they're congruent and they're corresponding angles, if M is the transversal. And if M is the transversal, M is intersecting A and B. Therefore, which lines are parallel? Then line A is parallel to line B. Okay, so we have established this as the case. Okay, so line A being parallel to line B. That's what we have established by that. Okay, and we're going to justify our answer. Well, how are we going to justify our answer? With that theorem, with the converse of the theorem, actually. But again, it doesn't matter. Just know this, right? You don't even know the name. You just got to know to say this. If corresponding angles are congruent, then the lines are parallel. Okay, so you don't need to label it, but you just got to be able to say that. Okay, or in our case, write this. This is your argument. Okay, so that's how that works. Okay, so that's how the corresponding angle converse works. Okay, let's take a look at another example. So let's look at a similar or the same diagram. Okay, and now we're going to say which lines are parallel if angle 6 and angle 7 are congruent, and justify our answer. So let's look at angle 6 and angle 7. Angle 6 is here, angle 7 is here. If that's the case, what is the transversal? Okay, so we have to know where our eyes are going. Okay, so if angle 6 and angle 7 are the case, what would be the transversal? It would be line B, right? Ooh. Line B in this case would be the transversal. Okay, so you got to see what's cutting. And if line B is the transversal and 6 and 7 are congruent, what are the two lines that are parallel? We have established then that line L is parallel to line M. Okay, and that's what we have established. So what two lines? You got to be able to see that transversal. Okay, remember the skill that I talked about in class, visualizing geometry. Okay, so we're visualizing those geometric concepts. Okay, so line L is parallel to line M. How do we know? Again, you have to know to say this. If corresponding angles are congruent, then the lines are parallel. Okay, if corresponding angles are congruent, then the lines are parallel. You don't even know what it's called. You just need to know to say it. You know what I'm saying? So make sure you are good with that. Moving on to the next thing. Okay, so now there's this thing that we have. It's called a flow proof, and we're going to talk about that. Okay, so we're going to talk about proving the converse of the alternate to interior angles theorem, and we're going to do a thing called a flow proof, and it shows arrows for the logical connections. I just want to present this to you because, again, we are using proofs. Okay, we are using proofs. Now, the first thing we can do first I'll show you the flow proof, and then we'll make the two-column proof because we still need to be good with the two-column proof. Okay, so the flow proof is this. Well, here we have the thing. We're given that angle 4 is congruent to angle 6. So we see angle 4 here and angle 6 here. What we have to do is prove that line L is parallel to line M. And the only thing we know, right, right now is that if corresponding angles are congruent, then lines are parallel. So if we can somehow prove that angle 2 is congruent to angle 6, we're hunky-dory. So then this thing exists called a flow proof. Now, how does that work? So the first thing we want to do is start with just like normal, you always start with a given statement. Okay, so given statement. Angle 4 is congruent to angle 6. We know that, right? So angle 4 is congruent to angle 6. Now, what's the deal? How can we get to show that line L is parallel to line M? If we can show these corresponding angles being congruent, we'd be money, right? Totally money. So we somehow have to get from angle 4 and angle 6 to angle 2 and angle 6 being congruent. That's the game plan, right? So what do we know about angle 4 and angle 6? Well, their congruence given. How do we throw angle 2 in the mix? Hopefully you remember a thing. Do you notice what's going on between angle 4 and angle 2? Why, yes, they are vertical angles. And we know that vertical angles are congruent. Okay? So this is how the flow proof works. Like you say these things and you draw arrows. Okay, so the flow proof says, well, we're going to take those two arguments, flow them into the next argument. Right? Well, what would be the next argument? Take a look at what we have. Hopefully you see that the next argument is going to be that angle 2 is congruent to angle 6. How can we make that argument? Angle 2 being congruent to angle 6, we can easily make that argument because of the transitive property of congruence. Okay, so we can make that argument right there because of the transitive property. right? 2 and 4, 4 and 6, 2 and 6. Ta-da! Transitive property of congruence. So all we have to do now is close the deal, seal the deal. We can now simply prove line L is parallel to line M. How do we know? Because the thing I've been hounding you about. If corresponding angles are congruent, the lines are parallel, right? So if corresponding angles are congruent, then lines are parallel. So how can we do the exact same thing but with a two-column proof? Remember how the two-column proof works. You have your statement, right? And then you have your reason. Okay, so a statement and a reason. Okay, so we do the same exact thing. So we start with our statement. Remember how the statement should begin? You start with your given statement. The statement is angle 4 being congruent to angle 6. What's the reason? It's given. Okay, so that's what we know. Right, now we're going to start doing is making these same jumps. We know the next thing is to say, well, that angle 2 is congruent to angle 4. Right, so we're looking here. I need to get to 2 and 6. That's my game plan. So I know that angle 2 is congruent to angle 4. And how do we know? Because the reason is vertical angles are congruent. Okay, that's our reason. We have to know all of that. You know what I'm saying? So, yeah, I know it's a bear. Mr. Katz, do I have to write that? Yes, the answer is yes. Yes, you do. So now we have to establish the next thing, right? And the next thing, of course, is to say that, well, 2, 4, 4, 6, therefore 2, 6, right? That's a thing. What is that thing? That is the transitive property of congruence. Okay, so we see how that works. Transitive property of congruence. Man, we're still doing this. Yeah, we're going to be doing this all year. Get used to it. And then lastly, we can close the deal, right? We can totally close the deal. What happens if angle 2 and 6 are congruent? Well, they're corresponding angles, right? So we can go ahead and jump to the thing. If corresponding angles are congruent, right? We have to write the whole thing. If corresponding angles are congruent, then lines are parallel, right? So we have to know that. So I don't care what you call it, you just got to know to say it. Then lines are parallel, okay? So what would be the statement for that? Well, then we close the deal. We have just now proven what we set out to prove. What do we prove? That line L is parallel to line M. Deal sealed, all right? Mic drop. So that's a flow proof, and I just wanted to show you how that works. Okay, so now we know what a flow proof is and how that works. But let's have some fun, shall we? Okay, so we're talking about all these theorems and their converses. So here's a neat thing. Let's use some algebra. Okay, let's use some algebra. So what is the value of x for which line A is parallel to line B? Okay, so line A is parallel to line B. Well, what do we know? If line A were to be parallel to line B, then we have to see that these are same side interior angles. Okay, we have to see that these are same side interior angles. But what can we say to bring in parallelism, right? How do we bring parallelism to that? We can say if, right? If, I'll use black ink for this. If same side interior angles are what, right? What? What's the word? What's the word? If same side, we're dealing with same side interior angles. If same side interior angles are supplementary, make sure you know that, right? Same from the last lesson as well. If same side interior angles are supplementary, then guess what? Then lines are parallel, okay? Lines are parallel. You got to know that, okay? So this is, again, the theorems that you have to know. It's not the titles so much as what they are. If same side interior angles are supplementary, then lines are parallel. That means if these two things are supplementary, then A would be parallel to B. So guess what supplementary means? Supplementary means, if you recall, supplementary means that, well, the two or things, it doesn't matter how many, add up to 180. Okay, so what supplementary means, the two things add up to 180. So in this case, 2x plus 9 and 111. So 2x plus 9 and 111. If we were to add those together, we would get 180, and the rest is some algebra work. Okay, so what's the first thing we do? Starts with a C, ends in bind-like terms. And so we have 2x plus 120 would be equal to 180. right? And then we use the subtraction property of equality. We subtract 120 from both sides, and we end up with 60. And then we use the division property of equality, and we find x to be 30, okay? Now there's another way of doing this, okay? If we know that these two are supplemental, right, they both add up to 180, this angle has to be 69 degrees. It has to be, because 111 plus 69 is 180. So we can also establish that, well, this other angle has to be 69 degrees. So that means 2x plus 9 has to be 69. Okay? And then what we can do then is still the same thing, right? Then we actually jump into subtracting 9 from both sides. 2x equals 60, and that should look familiar. Either way, x is going to be 30. Okay? So we have found the value of x. The key is to know technically the converse of the same side interior angles theorem, but just know what it says. If the same side interior angles are supplementary, then lines are parallel. True? 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 Good. Next. Okay. So we're done with that. Hooray for algebra. I love algebra. Anyhow, moving on. Some more algebra. It's like the same question, right? What is the value of W for which C is parallel to D? C being parallel to D. Well, notice this is the transversal here. Okay, so if we have the transversal here, what would that mean about 55 and 3W minus 2? Okay, if we're going to establish that these are parallel, then we have to establish that these two angles are congruent because they are corresponding. Okay, so these are corresponding angles, right? And what do we know about corresponding angles? That's, well, if corresponding angles are congruent, then lines are parallel, right? If corresponding angles are congruent, lines are parallel. Okay, so we have to go from there. Then lines are parallel. All right, so with that knowledge, well, what do these two angle measures being congruent mean? Well, it means we have an equation. It means that we're saying 55 is equal to 3W minus 2. Okay, so all we have to do now is solve for W. And I'm going to use the addition postulate of equality, or addition property, the addition property of equality to get 57. And then I'm going to use the division property of equality to get 19. And now we know W is equal to 19. Or very similarly, if you know that, well, it's the same thing, right? So, there you go. And that's how we know. That's how we know some stuff. So hooray, algebra. So let's take a look at some stuff that's going on in the book. Okay, so let's take a look at some questions here. So check this out. Lesson check. State the theorem or postulate that proves that A is parallel to B. Look what's going on in number 1. We have these two angles. How do we know A is parallel to B if these two angles are congruent? So what's the postulate or the theorem that we're using? If corresponding angles are congruent, then lines are parallel. Okay, we have to know that. These are corresponding angles. So if corresponding angles are congruent, then lines are parallel. How about this one down here? Okay, so at number 2. What's interesting about number 2 is you got to take a look at here. Yeah, we have that y and that 65. That's not important. What's important is that we have these single arc, okay, one arc. And one arc means they are congruent. Okay? So how can we prove that that A is parallel to B if those two are congruent? Guess what those lines are to one, or those angles are to one another? Those angles are alternate interior angles. And so we can use that argument. We can argue if alternate interior angles are congruent, then lines are parallel. Done and done. All right? So now, the third question. What is the value of y for which A would be parallel to B? Now, take a look at y. Here's y. And take a look at the other angle, 65, right? So what do we know about those? Those are same side interior angles, right? And same side interior angles must add to 180. Okay, so same side interior angles must add to 180 if the lines are going to be parallel. Okay, so if same side interior angles are supplementary, then lines are parallel. So in that case, we have our equation. We simply subtract 65 on both sides. We get 115. Okay? Okay. So check this out. Explain how you know when to use the alternate interior angles theorem and when to use the converse of the alternate interior angles theorem. You know my answer to this? It doesn't matter. My answer is I don't care. Because we have the two the theorem and its converse. It all depends on what you're trying to prove. What are you trying to prove? Okay, if lines are parallel, then alternate interior angles are congruent. Are you trying to prove that alternate interior angles are congruent, or are you trying to prove that lines are parallel? So it doesn't matter which one you call the thing, which one you call the converse. It just matters what you're trying to prove. So the answer to this particular question is, who cares? What are you trying to prove? Okay, so that's my answer to that. How are flow proofs and two-column proofs alike and different? We've done that. And then number 6, error analysis. I like this question. Okay, so take a look at this. A classmate says that line AB is parallel to line DC. AB parallel to DC. Based on that diagram to the right, explain your classmate's error. So let's say this. What's going on with 97 and 83? Right? Hopefully you know that 83 plus 97 is equal to 180. What? What does that mean? That means they're supplemental. If that's supplemental, how in the world are these going to be same side interior angles, right? That's what we need to know. If we're looking for parallel, how can we establish that these are same side interior angles? If we can say that DC is the transversal, okay? If we can call DC the transversal, we would know that, okay? So we would know that. Explain the classmate's error. Dude looked at the wrong thing, okay? Classmate looked at the wrong thing. If these are supplemental, DC is a transversal, then guess what? It's AD that's parallel to BC. There's your error. Okay, so the diagram shows that AD is parallel to BC, or segment or line, whichever way. You know what I'm saying? So there's that. And I'm done. The rest is practice. Practice, especially with proofs. Make sure you are writing. Yes, you have to write. So quit whining and get on it. I'm out.